Let's continue this lesson 5.2 about graphing functions by understanding a few more parent functions. And let's do this time radicals. Let's start with the square root of x. How does the parent function of the square root of x looks like? Because remember, as the degree or the power or the exponent on the function changes, the shape of the parent function is also going to change. We're going to look at first at the left side of the graph. We're going to look at the second quadrant. It actually doesn't make a difference if we look at the second or the third quadrant because there is actually no graph. There is no graph right there. That's why we're putting the red lines right away. Now, let's take a look at the right side. And that's the first quadrant. And here we do have a graph because we do have a curve starting from 0 all the way to infinity. So as we can see, we do have a graph on that first quadrant. We have a graph on the positive side of y and on the positive side of x. So let's write the domain and range for this problem. For the x-axis, only the positive side of x is in orange because we only have a graph on the positive side of x. So the domain is all the values of x greater or equal than 0. We don't have any negative values. And for the range, that means the y-axis, only the top part, the positive y, has a graph. Only the positive part of y is orange. In the bottom half, we don't have anything. There is no graph on the bottom. So we make it red, which means the range is also all the values of y, or f of x, greater or equal than 0. But let's clean this up and let's change the radical because, yes, this is the graph for the square root of x, and actually is very similar for all the radicals with even indexes. But let's change the index, let's change the function to radical 3. Let's make now an odd index. Radical 3 is an odd index, and this is going to change the graph a little bit because now we're going to have a graph on the left side of this axis. We're going to have something here, and it's going to be a very similar curve that what we have on the first quadrant, but it's just in the opposite direction. It's going to come all the way from negative infinity until we reach the 0. The remaining part of the graph is the same as we had it. It doesn't change. That part is still included. That didn't change. The new thing, the new aspect of the function, as we have an odd index, is the fact that we now have something on the left side of the graph. And now our domain and range are going to change because look at the x-axis. The entire x-axis is orange because we do have a graph on the left side and on the right side of the axis. So the domain is all real numbers. And same thing is going to be about the y. Because the range, which represents the y, everything on the y-axis is orange. We have a graph on the bottom, we have a graph on the top, so the range is also all real numbers. So depending on the index of the radical we have, the domain and range of the function changes. Let's analyze one last function. Yes, there are many more parent functions, but we're just analyzing the basic ones first. As we get into further lessons and further units, also in Algebra 2, we're going to review some other graphs. We're going to get deeper into other parent functions. But for the moment, let's review the basic ones, and let's end with the absolute value of x. Because technically we could say that the power of this function is 1 because the x is to the power of 1, but it's not a simple straight line as the first graph we analyzed in the previous video, because the operator of the absolute value also changes the shape of the graph, like having an operator, having a logarithm, which we're going to learn in Algebra 2. Different math operators change the shape of our graph. And for the absolute value, let's remember that the absolute value of 4 is 4, and the absolute value of negative 4 is also 4, which means the absolute value just turns everything into positive. And that's going to change our graph a little bit because now if we look at the second quadrant, our graph starts from the second quadrant. It's a diagonal line going downwards on the second quadrant. So we have everything on the negative x and on the positive y. But then it doesn't keep going straight down like if it was an inverse x to the power of 1. It actually goes up again, like it bounces on the x-axis. It goes up from 0 all the way to positive infinity. And this is our absolute value graph. So depending on the math operator, we have a different graph. Then, if we write the domain, look, we have a graph on the left, we have a graph on the right. The domain of this function is all real numbers. And for the range, we do not have any graph on the bottom, only graph on the top. So the range is just the values of y or f of x, depending on how the problem wants you to write the answer, greater or equal than 0. And this is just some of the basic parent functions we're going to analyze in this lesson.